Today what we're going to talk about is the point of intersection. Now, I know we've been talking about the equation of a line, which is y equals mx plus b. And during our last lecture, we finally figured out what m was. We know that m is now the slope of a line, which is really the angle at which the line is projected, or the grade that the line is sloped. So now what we're going to do is talk about b. What you may have realized during some of your classwork on slope is that b is actually the y-intercept. So one of our objectives for today is what is the y-intercept and why does it hold crucial information? Now, when I talk about the y-intercept, I talk about it being where our linear equation intersects the y-axis. Okay, so the y-intercept is where a linear equation does just that. It intercepts the y-axis. And the word intercept is really, what it means is where the line crosses the y-axis, wherever it passes over the y-axis. So it makes sense that if we're looking at the x-intercept, we're thinking about wherever a linear equation crosses the x-axis. And lastly, what is the coefficient? Now, the coefficient is the number that is attached to the variable by multiplication, and in this case, that's our m. Now, previously we didn't know what m was, but now we know that m is slope. Therefore, m is most commonly our coefficient. Right? So the way that we're going to talk about the intercepts is by looking at an example, and this is from your Moving Straight Ahead text, page 14, number 6. And the graph shows a walkathon pledge from 3 different sponsors. Now, the first instruction asks us to describe each sponsor's pledge plan. Now that we know our y equals mx plus b, we can describe the pledge plans using that equation, using the slope, and using the y-intercept. So we have sponsor A, and sponsor A, I'm just going to pick 2 points that lie along my staircase that I know I can use to find the slope. So the first point is 0, 0, and my second point is going to be 1, 3. So I'm going to use 0, 0, and 1, 3. Now, if you remember, our slope equation is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1, which in this case specifically is 3 minus 0 over 1 minus 0. And when I simplify that out, I get 3 over 1, or just the whole number 3, and that's equal to my m. So the equation I can write for sponsor A is y is equal to 3x, and now I need to include my y-intercept, which is b. Well, where does my line for sponsor A intersect the y-axis? Well, here is my axis, and the line from sponsor A intersects my axis at 0. So the conclusion of my equation would be plus or minus 0, but since it's not, 0 doesn't affect our equation, I could also choose to leave that out. It would not be incorrect if I didn't include a y-intercept. So this is the way I would describe my pledge plan for sponsor A. For sponsor B, we would have to pick 2 new points, and looking along the line of sponsor B, I could pick this point and this point. And I'm really picking points that intersect a grid line on my graph, just at random. You know, obviously sponsor B, there's a lot of points that you could pick. I'm just picking what's jumps out at me, basically. So for my first point, I have 3, 5. And my second point is 6, 5. Looks like a 6. So again, put that into my equation. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. 5 minus 5 is 0, over 6 minus 3 is 3. Now, whenever I have a 0 in a numerator, that just tells me that this fraction simplifies to 0. I have 0 parts of my whole. So when I write my equation, my m is equal to 0. Now, m is 0. M times x will always be 0 because 0 times any number is just 0. I could say 0x, but this will, in fact, equal just 0. So when I write my equation, I can leave that piece out and just include my y-intercept. Now, where sponsor B's line intersects the y-axis is actually around 5. So my equation for sponsor B would be y is equal to 5. That's kind of the outlier. That's kind of the weird example that you would see. When we look at sponsor C, again, we could pick 2 more points. I'm going to pick this one and this one. So my point 1 is 0, 2. And my point 2 is 2, 5. Write out my equation, 5 minus 2 over 2 minus 0. Do my subtraction, 5 minus 2 is 3. 2 minus 0 is 2. And if I plug in my m value to my equation, I get y is equal to, oops. I get y is equal to 3 halves times x, and my y-intercept for this equation is actually positive 2, so plus 2. Now I've got all my data here for the descriptions of my pledge plans. So this was really the goal of being able to write the equation using both the slope and now the y-intercept. The y-intercept is significant for these types of equations because especially in this example it talks about the sponsor pledge plans. And basically what it's telling you is that at the distance of 0, where my x value is 0, this is the amount of money that my sponsor is going to give me. So before I even travel at all, what amount of money will my sponsor provide? Well, sponsor A says, if you don't travel, I'm not going to give you any money. Sponsor C says, if you don't travel, I'll give you $2. And sponsor B says, I'm going to give you $5 from the start, whether you travel or not. So this information at the y-intercept on the y-axis is important for certain types of data sets. The coordinates of 2 points on each line, what information does each point represent for the sponsor's pledge plan? I think we understand that the x and y coordinates are crucial. Some important points may be where those lines intersect, the y-intercepts, and also if there were any on this graph, specifically the x-intercepts. Okay? These are just a few reflection questions. If you would like to answer these in your notes, they may help you for tomorrow's classwork, but if not, they will not harm your learning in any way. But it might be a good idea to give them a look.